right, so here is lesson 1.8, and we are talking about inverse functions. So even though it says unit 1, we are including this in unit 2. It just makes more sense here. So the topic of today's lesson is how do we find inverse functions? So you just naturally use inverse operations anytime you solve an equation. So if I had something like 3 times x, and you needed to solve for x, you would divide by 3. And your outcome is x. If I had the square root of x and you need to solve for x, well, you would square both sides and your outcome would be x, because those are inverse operations. Now, what we're doing with inverse functions is we're going to have, if I plug one function into the other, my outcome would be x. So it's kind of the function that would undo the other function. So how do we do it? And the base idea, most basic idea, is that we are going to switch x and y. Okay, switch x and y and solve for y. You'll hear me say this all the time. Anytime you're finding an inverse function, switch x and y. And so example 1 here, we've got a linear function. Let's go ahead and graph the function and see what we have. So we have an intercept of 1, a slope of 1/3. So I go up 1, right 3. We're down 1, left 3, can't count. And we've got that function here. Okay, now our domain is x is an element of all real numbers. And our range, y is an element of all real numbers, because there is no limitation to what x or y could be. So now let's move to its inverse function. So I said, how do we do it? We switch x and y and solve for y. So f of x is just another name for y. And so we are going to switch x and y. So I'll have x equals 1/3 y plus 1, and then solve for y. So I'm going to use my reverse order of operations to solve for y. So I subtract 1 from both sides, and then I'm gonna, I can divide by 1/3, or it's going to be easier if I just multiply both sides by 3. And I get y equals 3x minus 3. And so now I'm going to put it back into function notation. What we were finding was f inverse of x. And you see that it looks like f to the -1, but what that means is the inverse of f, or f inverse, is 3x minus 3. Now, if I go ahead and graph that, well, I know that's a line again. The intercept is -3, the slope is +3, so I go up 3, right 1, up 3, right 1, I can keep going, and then draw my line. Okay. And, well, it's, again, a linear function, so there is no limitation to what x can be. X is a member of all real numbers, and x is an element, or excuse me, y is an element of all real numbers. That would be my domain in range. All right, so pretty easy. So how do we find an inverse? Switch x and y and solve for y. Well, you know, it's got to be a little bit more complicated than that. So we are going to go to a little bit more complicated function. So this time we have a square root function. Okay. And so I know the shape of a square root function is that root ramp. I have a shift of right 2 and up 3 using our function transformations. So I come down here, sketch it. I will have right 2, up 3. And this is the basic shape of our graph. Okay, simple enough. Well, let's go down. Let's identify the domain and range. So what are all the possible x values for my domain? Well, it's been shifted right 2, and so the smallest x value I can have is 2, but then I can plug in anything higher. And then my range, well, the whole thing has been shifted up 3, so the lowest y value I have is 3, and then it goes up to infinity. Pretty cool. All right, so now let's find the inverse. How do you find the inverse? Switch x and y. So here's my y value. So I switch x and y, so I say x equals the square root of y minus 2 plus 3. Okay? So now solve for y. So we switch x and y, solve for y. So I'm going to subtract 3 from both sides. And now we got to get rid of that square root. So I'm going to square both sides. And we could multiply this out, but it's going to be easier to graph if I leave it this way. So I'm not going to expand, I'm just going to leave it as x minus 3 squared. And then finally I need to add 2 to both sides. So I have x minus 3 squared plus 2. So my inverse, now I put it back into function notation, my inverse function is the quantity x minus 3 squared plus 2. All right, well, we know what that looks like. That is a parabola. It's a quadratic function, and it's been shifted right 3 and up 2. So let's shift this function right 3 up 2. Here's my vertex, and I can go up like this and up like this. Okay, and so if we identify the domain and range, well, we know that x can be all real numbers in a parabola. And y, the whole thing's been shifted up 2, so y is greater than or equal to 2, or I would say it's from 2 to infinity. But we have a problem. Let's go back up to the original graph here. You'll notice that there is some symmetry happening between these graphs. Maybe you notice it, maybe not, but what's happening is that it's being reflected across the line y equals x. An inverse function is always going to be symmetric about the line y equals x. Now, if I look down at our more complicated example now, I draw this line, and I see they're somewhat symmetric, but I've got this whole right side over here that doesn't have a match on the blue graph, okay? Because I have half of a parabola, sideways parabola on my blue graph, but I have a full parabola with the red inverse function. Well, this can't be, okay? They have to be symmetric exactly. And so how do I make them exactly the same? Well, or exactly symmetric? I'm gonna get rid of the left side. Who knew you could do that, huh? And so now we have exactly symmetric functions. But what we did is we changed our domain. We changed the domain. Now this red graph, x can't be all real numbers. X can only be greater than 3. So I'm going to come back and I'm going to change this domain. Say, oops, nope, we're going to change this. X has to be greater than or equal to 3. And in interval notation, I would say 3 to infinity. Well, let's back up and let's see. You know, there are some similarities here between these domains and ranges. Notice that the domain of my original function is the same as the range of my new function. And the range of my original function is the same as the domain of my new function, the inverse. And that makes sense because what is an inverse function? Well, it's switching x and y. So if that's what an inverse function is, then it makes sense that I'm going to switch all my x values with y values and vice versa.